We have a specific formula for confidence intervals. Again, we're looking for something where we can say with 90% confidence, this is the interval, it's going to fall between this interval. So we have this crazy looking formula here, and we're going to introduce some more language. Now, it's the formula for the confidence interval of the mean for a specific little crazy A type thing here. That's alpha. Okay, and when we talk about this alpha right here, alpha is going to represent the total area, okay, area, think standard normal distribution curve, in both tails of the standard normal distribution curve. Okay, so this alpha represents the total area in both tails. Give me a quick peek here as we look at this. If we're saying with 95% confidence that mean's going to fall between this interval and this interval, we have these two tails. Okay, so alpha is going to represent this total area. Along with that, what you're usually going to see is alpha over 2, and that's going to represent just one tail. So our formula here, we're going to take our mean, our sample mean, minus, and you see we have this z alpha sine over 2. Okay, we're going to read that as z, however you want to write that, sub alpha over 2. Okay, just for your information, that's how that's read. So what we're going to do is we're going to do the mean minus z sub alpha over 2 times our standard deviation divided by the square root of our sample size, or the number in our sample. And then we'll do the same thing over here, because again we're creating an interval. Mean plus z sub alpha over 2, and then times our standard deviation over the square root of the number in our sample size. But here's what I want you to focus on, because this is information that seems maybe minute right now, but you're going to need to know it. We're going to use these numbers. 90%, we're using that z sub alpha over 2 is 1.65. 95%, we're using 1.96. And 99%, we're using 2.58. Know to refer back to those numbers. Now, where do those numbers come from? They're coming from our standard normal distribution. We're going 1 minus the 95% and dividing by 2, and that's what's left over. Okay, so just know that those numbers are coming from. More importantly, though, know to use these. 1.65, whoops, 1.96, and 2.58. What are we saying when we talk about that stuff? Again, this right here. We're talking about 95% sure that our mean's going to fall between this, or fall within this interval, and so we have that little bit of error on the outside. This z sub alpha over 2 times the standard deviation over the square root of our n, that is our maximum error of estimate. So our maximum error of estimate is the likely difference between the point estimate and the actual value. Okay, so that's that right here. Let's look at an example or two. A researcher wants to estimate the number of days it takes an auto dealer to sell this Chevrolet Aveo. I think I said that right. A sample of 50 cars had a mean time on the dealer's lot of 54 days. Actually, we have two things there. We have our sample of 54, our mean of 54, our sample of 50. It has our standard deviation of 6.0. And we want 95% confidence. So we'll go back here. What is 95% confidence? 1.96. Z sub alpha over 2 is 1.96. Here's a cool thing. you have all that information. All we're going to have to do is plug it in to our interval formula, and you're going to get the population mean with 95% confidence. Okay, so a lot of crazy symbols, but once you can identify things, it's just plugging numbers in and solving. So our mean is 54 minus our z sub alpha over 2, which we said was 1.96, times our standard deviation divided by our sample, square root of our sample. And then we do it all over again, but this time we're going to put a plus sign in. And what we end up getting is 54 minus 1.7. Our population mean is going to fall between that and 54 plus 1.7. That works out to be 54.3 and 55.7. Now, this is one way to write it. We do have another way, and sometimes you're going to see it, remember, with like a plus or minus. So what we do is, just for your information, I'm not saying you have to write it like this, but you will see it like this sometimes. If you add these together and divide by 2, that works out to be 54. So another way of saying this is we could say 54, well, basically our mean, right? Plus or minus, how far off the mean are they? Well, 52.3 is minus 1.7, 55.7 is plus 1.7. So we can either say it as 52.3, this interval here, however you want to say it, or we could use this, 54 plus or minus 1.7. They basically mean the same thing. Well, what are we saying? We're saying with 95% confidence. With 95% confidence, one can say the population mean falls sorry about the scribbling, between 52.3 and 55.7 with 95% confidence. That's pretty good. Let's look at one more example. Okay, let's do the same thing. Ages of automobiles. We have 30 adults here, so there's our N. The mean age is 5.6 years of that automobile. The standard deviation is 0.8, and we want 99% confidence. Well, if you go back to this information here, 99% is 2.58. So our z sub alpha over 2 is going to be 2.58. Okay? Now, using that same formula, I'm not going to rewrite it, so look at it if you need to. 5.6 minus 2.58 times our standard deviation divided by our sample, square root of our sample. And again, all we're doing is we are finding the interval that we can say with 99% confidence that the mean of the population is going to fall between. Okay. You figure all this out, we get 5.22, which is less than, or it's going to fall between 5.22 and 5.98. Okay? So we can say with 99% confidence that the mean age of a person's primary vehicle, it's going to be between these two numbers. And a lot of times you're going to see a rounding, okay, and we'll talk a little bit about rounding later. Don't stress too much about that, okay, but we can say with 99% confidence, using all of this information, that we know that a person's, of our population, a person's primary vehicle, that mean is going to fall between these two numbers. So, important things to take away. First of all, know this is all based on, again, that standard normal distribution. Know these confidence intervals, 90, 95, and 99%. Knowing that, we can figure out the confidence interval overall.